The board just approved your AI initiative. Now, you need a budget, but your current estimates are completely wrong. You are staring down a financial autopsy waiting to happen. Today, we are dissecting the true cost of AI development in 2026.
$100 million? The internet constantly feeds you these massive frontier model headlines. It is a total distraction. Those numbers describe one-time infrastructure runs. They involve thousands of GPUs. They require massive research teams. They have absolutely nothing to do with your corporate roadmap.
Training a frontier model from scratch costs $50 million to $500 million. Foundation model fine-tuning runs between $2,000 and $30,000. The real gap is not the build phase. The real gap is between a prototype invoice and the crushing reality of production inference costs.
Section 1. Analytical Postmortem. 3 tiers.
This is a rigorous, systematic breakdown of AI infrastructure costs. We move from a simple API proof of concept to a multi-region enterprise platform. Tier 1, the proof of concept, $15,000 to $60,000, a tight sprint to validate a single assumption against a vendor API. Tier 2, the mid-market production system, $80,000 to $350,000. This buys you a retrieval-augmented generation pipeline, foundation model fine-tuning, vector database like Pinecone. Tier 3, the enterprise deployment, $400,000 to over $1 million. Custom model training, dedicated MLOps infrastructure, human-in-the-loop review pipelines for regulated outputs. This is where corporate realities actually set in.
Notice how the year one total cost of ownership diverges sharply from the initial build cost. The build phase looks perfectly manageable. Then, inference, compute, and MLOps overhead hit the ledger. The math breaks down entirely. A mid-market project, building cleanly for $180,000, routinely hits $400,000 by month 18. GPU instance costs compound. Data preparation for retraining drains your resources.
Section 2. The hidden structural friction.
We need to analyze the unmentioned architectural debts, the systemic variables that vendor proposals deliberately omit. First, inference compute scaling nonlinearly. Second, model drift forcing aggressive retraining cadences. Third, human-in-the-loop review pipelines. Fourth, MLOps setup and platform engineering. Fifth, massive compliance uplifts for HIPAA or the EU AI Act. These are the structural factors that destroy initial estimates. They simply do not show up in the sales deck.
1.8 to 2.5 times. Over 24 months, the total cost of ownership routinely runs 1.8 to 2.5 times the initial build cost. This multiplier is non-negotiable for enterprise deployments. You absolutely must build this into your budget model.
Take human-in-the-loop operations. This is a recurring payroll cost. It is not a one-time engineering line item. If you handle regulated outputs, like flagged loan decisions or medical coding, you need human reviewers. That adds $60,000 to $250,000 annually. Vendors never put this on the infrastructure bill.
Then there is model drift. Models trained on first quarter data drift measurably by the third quarter. This forces a relentless and wildly expensive retraining cadence. Quarterly fine-tuning on new data adds $15,000 to $50,000 per cycle. Miss a cycle, and hallucination rates spike.
Inference compute scales non-linearly. A system processing 500,000 requests sits at a materially different run rate than a 5,000 request pilot. An H100 instance on Google Cloud runs roughly $33 to $40 an hour. If you need an A100 cluster on AWS, you are burning $38 an hour. LLM API costs dominate at scale. A low-volume pilot is cheap. A high-throughput production system completely breaks the linear budget model.
Section 3. Tactical action plan and system gates.
Maintenance and data preparation consume the lion's share of your budget. Actual model training is merely 15%. The massive slice for maintenance and monitoring takes up to 30% of your total allocation. Data preparation is another 25%. This includes labeling and storage. If your vendor proposal budget's only 5% for data prep, you will hit a massive scope overrun by month 2. Do not ignore the hidden tail of MLOps.
The crucial point here is execution order. Step 1. You must start with a fixed-price discovery sprint. Lock in your inference architecture before you burn capital on training runs. Step 2. Data preparation and annotation. Step 3. Model fine-tuning. Step 4. MLOps deployment and maintenance. This is a rigid framework. Skip a gate and your costs will spiral.
Section 4. The polarizing TCO reality.
Look at the 3-year horizon. Cumulative operating expenses frequently match or exceed the original build investment by year 3. Year 1 is pure capital expenditure. Build costs dominate. Year 2 shifts dramatically. Inference compute costs multiply. ML ops infrastructure requires constant attention. By year 3, the budget is entirely driven by inference scaling and maintenance overhead. Your operating years devour your capital. This is exactly where custom builds face strict mathematical reality.
We end on the single most critical decision you face. With year 3 maintenance effectively destroying custom budgets, can you mathematically justify not buying off the shelf? Defend your custom AI builds in the comments below. VI, packaging blueprint, thumbnail and on-screen visuals. Thumbnail text hook, AI budgets are lies. Thumbnail visual concept, a minimalist high-contrast layout featuring a pitch black background. The sole focal element is a single, glowing, blood-red invoice resting on a server rack. Stark, aggressive white text for the hook. Key graphic assets? A sharply styled line graph overlay for slide 6 showing the nonlinear explosion of inference costs as user queries scale. A stark, dark mode table overlay for slide 17, visually highlighting the moment year 3 OpEx overtakes year 1 CapEx.